All right, welcome back. We're going to finish up section 2.1. This is the part 2 video, so we're going to pick up at number 6, which is where we left off. And this question now asks us to find the equation of the tangent line to the function f of x equals x squared minus 3x plus 1, where x equals 5. So this is at a specific point, okay? So this is the one I was telling you that we can use one of either of the two equations where you're finding the derivative at a specific point, okay? So we have two different ones. So I'm going to write them up here at the top. We have f prime of a equals the limit as x approaches a of f of x minus f of a over x minus a. Okay, and I'm going to draw a line down here. And then we also have the derivative at a specific point using that difference quotient. The limit as h approaches 0 of f of a plus h minus f of x over h. Okay? Now, some of you like using this all the time because it's just that one difference quotient formula, and all you have to do is substitute in, that should be an a. Instead of f of x, you would be using the point f of a, whatever a is. In our case, it'll be 5. So this kind of is just the same formula, but, you kind of know it. This is the actual slope formula if you look at it, right, with x and 1 point. So x is going to be the x's, that doesn't change, and then this would be the 5 and the y value for 5. Okay? So it doesn't really matter which one you use. You can use either one. You don't have to do both. I'm going to do both with you just so that you can kind of see how to do that. All right, now for each of these, we need to know the function value when x is 5. Okay? So for either problem, I would need to know what is f of 5. So I'm going to do that up here. I got to plug in 5 into my function. So I would do 5 squared minus 3 times 5 plus 1. Okay? So I'm just going to plug that in there and see what I get. So this is 25 minus 15, that's 10 plus 1, so I get 11. All right, so I have the ordered pair. So I know that the point that I'm working with is the point 5, 11. Right? So I know that on both of these. I need to know the point. Okay? All right, so either way, whenever you're given a point, I need to know the y value. Sometimes they'll give you the whole point. They'll give you this in a problem, and sometimes they'll just give you x. So if they just give you x, start by finding y, okay? Because you're going to need that. All right, so let's look at this derivative. So now I'm going to find the derivative of this function at the point 5. A is 5. That's the point they gave me, okay? All right, so I'm going to write this out using my 5. So f of x is going to stay f of x. What you're changing is a is 5. And then that means the bottom would be x minus 5. Okay? So if you're using this formula, f of x is always f of x, and x is always x. That never changes. Okay? And then f of a, that's your y value, and then 5, that's your x value, a. So this is your x and this is your y. So here's where the point goes. All right. So that means I need to put in f of x here. So let's keep going. Oop, and I left out the limit as x goes to 5. Okay, so this is the limit as x goes to 5. All right, so f prime of 5. So now we have the limit as x goes to 5. And instead of f of x, we're just going to put f of x, which is this, x squared minus 3x plus 1. That is f of x. Now we're going to subtract f of 5. So what is f of 5? F of 5 is the y value, so we're going to do minus 11. And then we're going to do that over x minus 5. So now all we have to do is simplify the top. So the top will give me x squared minus 3x minus 10 over x minus 5. All right, so there's your limit. Now remember, we could do direct substitution at this point. If I do direct substitution, I'm going to get 25 minus 15, which is 10, minus 10, which is 0, and 5 minus 5 in the bottom, which is 0. Right? So my direct substitution didn't really help me. But that does tell me that I can continue and find an answer. Okay, so I'm going to factor the top. Factors x minus 5, x plus 2 over x minus 5. I can cancel the x minus 5s. So now I have the limit as x goes to 5 of x plus 2. And now I can do direct substitution again. So now if I put in 5 plus 2, I get 7. Okay. Now guys, remember the derivative. Go back, what is the derivative at a point? The derivative at the point is the slope of that point at that, on the curve. Okay, so think about this graph. Okay, so if I were to look at, let me do it over here. So if I was to graph x squared plus 3x plus 1, I don't know exactly what it looks like, but let's say it's doing something like that. Probably not, but let me get the actual, because I know you're going to tell me I was wrong. I know that's not quite what it is. So x squared minus 3x plus 1. I think it goes down under the, yeah, that's what I thought. Okay, so scratch that. All right, so I'm going to look at it again. All right, so there's the graph, okay? So we're trying to find what's happening at 5, okay? So that's up here somewhere. So let's say that's 1, 2, 3, 4, 5, okay? So what we just found is if we drew the tangent line there at 5, tangent line, the slope of that tangent line is 7. And that would seem right because it's pretty steep, right? It's a positive slope, it's going up. So that's what this is telling us. We just found the slope of that point with only knowing one value. We didn't have to have x2 and y2. We used the actual function for the second point, okay? So, that doesn't seem like much right now, but that's a very powerful tool that's going to help us in a lot of stuff this semester. All right, so that was using the definition of derivative at a point this way, okay? Now, if you want to use the definition using the difference quotient at a point, it would be this one. So let's look at how that would pan out compared to what we just did. Okay, so we're going to do f prime of 5. Okay, so a is 5. So this is now going to be the limit as h goes to 0 of f of 5 plus h minus f of 5 over h. Okay, so you can see the difference. This does not use the h's. This is a specific point. This is for a non-specific point, but we can make it a point if we wanted to. Okay? All right, so again, what does this mean? This means in place of the x's in your problem, you're going to replace it with 5 plus h. Right? That's what function notation always means. So now we have the limit as h goes to 0. So we're going to write 5 plus h squared minus 3 times 5 plus h plus 1. That's what that says to do. So 5 plus h squared minus 3 times 5 plus h plus 1. So again, that's the first part. That's just this. Then it says minus f of 5. Well, what is f of 5? That's the y value. So minus 11, and that's all over h. Now remember, this is h going to 0, and over here we went x was going to 5. So a little bit different setup, but we'll get the same answer. All right, so now we have the limit as h goes to 0. square this. So remember what I said, that's 5 plus h times 5 plus h, right? So you got to foil that out. And when you FOIL it out, you get 25 plus 10h plus h squared. Multiply this by -3, so that's -15 minus 3h. Then you've got the plus 1 minus 11. And now we're going to simplify, okay? So now we have the limit as h goes to 0. All right, we got a positive 25 minus 15, that's 10. 10 plus 1 is 11, and 11 minus 11 is 0. So all of those numbers add up to be 0. All right, then we have a 10h minus 3h. That would be 7h. And then h squared. And that's over h. All right, and like I told you before, we're going to divide both terms by the denominator. When you have one term in the bottom, that has to divide into everything in the numerator. So 7h divided by h is 7. H squared divided by h is h. All right, so there is your limit. And now we can do direct substitution. So now we're going to put h approaching 0. So 7 plus 0, we get 7. Okay? So either way, the derivative at 5 of this function is 7. So, to me, in my mind, this is a little bit quicker. I don't know that one is better than the other. You can do it either way. If you're asked to find the derivative at a specific point, then that's fine. Now, this question didn't really say find the derivative, right? It said to find the equation of the tangent line. So we're not quite done, okay? We need to now find the equation of the tangent line. So what were we doing on both of these occasions? We were finding the derivative, which is the slope. So remember, now we know the slope of that line is 7, okay? Remember, this line up here, the slope is 7. So now I know the slope is 7, and I know that ordered pair was 5, 11. And that's all I need to find the equation of the line. I need the point and I need the slope, right? Okay, so now I can find the equation. Okay, so we have the point, which was 5, 11. We have the slope, either way you found it, which was 7. So now we're just going to do our y minus y1 equals m times x minus x1. Find that equation of the line. So we'll do y minus 11, that's y1. M is 7, and then x minus 5. So we end up with y minus 11 equals 7x minus 35. And then just add 11 to both sides. So we get 7x minus 24. Okay. So there's your equation of the tangent line. Okay. So again, I know I spent a little bit of time on this. I promise I won't spend a whole lot, but finding the derivative is the basis of, other than doing limits, which help you get to this point, you got to understand what a derivative is, okay? And some of you, I know, have issues with just lines. You don't really understand the slope and what that is, so you really need to have a good understanding to do well from here on out. So please let me know if you need help with, how to set this up. Some of you have the issue of function notation. You don't understand function notation all that well. So there are a lot of little algebra pieces in these kinds of problems that if you're struggling with, it makes it difficult. So please, 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 Zoom with me, go to tutoring, whatever, but practice this and make sure that it all makes sense to you. Because if it makes sense to you, it's going to make your life a lot easier moving forward. Okay? I promise you that. All right, so that was number 6. So now let's move on to number 7, which is similar. It's just, a word problem, but same kind of work that we have to do. All right, so we have a person standing on top of a 200-foot tall building, throws a ball into the air with a velocity of 96 feet per second. The function s of t equals negative 16t squared plus 96t plus 200 gives the ball's height above the ground t seconds after it was thrown. Find the instantaneous velocity of the ball when the time after 2 seconds, right? When time is 2. Okay, so that's instantaneous velocity. Remember what I told you. When the word instantaneous is involved, that means you're only going to be given 1 point. So that means we're doing derivative, okay? So I need to know how to find the derivative at 1 point. So that's just what we got done doing. So we're either going to use this function or this one, right? Either one of those will work. So I'm going to start with the first one like I did before, okay? So if I write that down, the derivative, let me write the formula and then we'll make it look like what we have. Okay. All right, so there's what we have, but now we don't have f of x, we have s of t, right? So again, this is, do you understand function notation? Okay, so let's let it look like what we are trying to do. Okay, so instead of f prime of a, we would have s prime of t. Okay, so this would be the limit as t goes to and we're doing 2, right? So I'll keep a there for a minute, but that's going to end up being a 2, but let's keep that there. So then we have s of t. That's the function. And instead of f of a, we're going to have s of a. And then over t minus a. Okay. So instead of using f of x, we're using the function s of t. So what we are doing, s prime of 2. Right now our time is 2. So we're going to do the limit as t goes to 2. Of s of t minus s of 2 over t minus 2. Okay, so that's what it would look like in terms of this problem. So part of, the notation is, do you understand functions and what the function is? So remember, f of x was the original function. So in our case, the original function is s of t now. That's here. So instead of the variable x, we're using the variable t. And then a and f of a are the ordered pairs that we were using. Okay, so that would be 2 and then whatever s of 2 is, right? That's the y value. Okay, so same setup, just this is kind of how it looks like with our values. Okay. All right, so let's think about this first off. First off, we need to find the ordered pair to what? All right, so we're going to plug 2 into here. Okay. So we can do that in your calculator. So we're going to do negative 16 times 2 squared plus 96 times 2 plus 200. Okay, so plug in 2 into here, however you want to do it, and get your y value. And that should give you 328. Okay. All right, so let's think about this graph. All right, I know it's a parabola. I know it opens downward because of the negative. I know this is the y-intercept. So here's the y-intercept. So I know this graph has to go something like that, right? It's a parabola. And what I am trying to do is find the instantaneous velocity of this ball at 2 seconds. So way up here, I know that is 2, and I know this is 328, the y value. So I know those ordered pairs. I know the function, I know that. So what am I looking for? I am looking for the slope of that tangent line. That is what I'm looking for. Okay, so let's think about this. First off, look at that line, and that tells me that this line is going up from left to right, so my slope should be a positive number, right? So we're going to learn coming up about, the signs of the slopes and how that affects velocity and things like that. So keep that in mind. If you draw a picture and look at it, I know that my slope value should be a positive number. Okay, so let's find out what it is. Okay, so we're going to do s prime of 2. So we got the limit as t goes to 2. And then we're going to plug in s of t. So remember, that's the function. So that would be negative 16t squared plus 96t plus 200. That is s of t. Minus s of 2, which is the y value, right? So minus 328 all over t minus 2. All right, what does that equal? That equals the limit as t goes to 2. Okay, so all we can do here is add the 200 and the negative 1 and the negative 328. So let's do that. So positive 200 minus 328, that leaves you a negative 128. All right, so again, this is a limit problem. So the first rule of thumb is direct substitution. So if I plug in 2 into this problem, I am going to get 0 over 0 right now, which means I can continue simplifying and get an answer. Okay, so I'm going to do that. All right, so I can factor out, and I'm going to go ahead and factor out a negative 16 so that this first term becomes positive. So if I factor out a negative 16, remember your signs are going to change. That's going to give me a positive t squared minus 16 divided by 96, that would be minus 6t. And then negative 128 divided by negative 16 is going to give you a positive 8. Okay. All right, so let's factor. So we have negative 16, and then this factors t minus 2, t minus 4 over t minus 2. So you'll see the t minus 2's will cancel out. So now I'm left with limit as t approaches 2 of negative 16 times t minus 4. All right, so there's my limit. I've simplified it. So now I go back to direct substitution. So I'm going to plug in 2 for t. So negative 16 and then 2 minus 4. That gives me negative 16 times negative 2. And that was a positive 32. Okay, and in this problem, we were doing seconds and feet. So this would be 32 feet per second. So that's the velocity after, or when the ball is in the air after 2 seconds. Okay, 32. Now, if you want to think about this in terms of velocity, so again, I'm just bringing this to you because this is what we're getting ready to look at. When he first throws the ball, okay, it said the initial velocity was 96 feet per second. So when he was right here and he threw the ball, okay, velocity was 96. Look at the slope there. That's a much steeper line. So after 1 second, okay, we're going to have a number probably between 96 and this 32 because it's not quite as steep as this line, but it's steeper than this one. So notice what's happening up here. Here's the tangent line. Okay, that velocity of the ball somewhere right here is going to be 0. And then it's going to start coming back down. Okay. When you get to this side of the curve, slopes are going to be negative. velocity will be negative over here because it's coming back down. Okay? So those tangent lines are important because it tells you a lot of information about the speed of, in this case, the ball, but of any object. Okay? So that's what we just found. That was the instantaneous velocity. All right, now, for those of you, and I don't have to go through the whole thing, but let's say, okay, same problem, but let's look at the other formula, okay, just real quick. I'm not going to go through it all. You guys can kind of finish this. But if we did the other one, the limit as h goes to 0, f of a plus h, right? What if you wanted to do that instead of the way I did it? So you guys, and that's perfectly okay. So this would go in place of the t's, right? So this would be negative 16. Take that back, we're going to do 2, right? Okay, and yeah, this is s. Let me redo that for you. Here's our function. For derivative, let me change it up for you. I don't want that to mess you up. All right, so what we're going to do is we're going to do s of 2 plus h minus s of 2, still getting it wrong, over 8. Okay, so same thing, but we're not doing function f, we're doing function s, and then we're using a is 2, right? Okay, so we would have a problem. So we would do negative 16, 2 plus h squared, plus 96, 2 plus h, plus 200. So this is the function, and in place of t, I'm going to put 2 plus h. So remember it was negative 16 t squared, so I put 2 plus h there, plus 96 t, put 2 plus h there, plus the 200, and then minus s of 2, which you're still going to do minus the 328, all over h. Okay? So you could do exactly the same thing. You would FOIL this out, distribute, right? Add your like terms. Okay? On this one, you would not need to factor. Okay? Once you add your like terms, then you'd be back down to where you cancel the h's out of each term and then plug in 0. So, you know, which one is easier? I don't know that either one is easier. They all have their steps, so you guys just need to decide. Typically, once you pick a way, that's the way you're going to do all your problems. So you decide which of those two formulas at the point you want to use, okay? But that's how you would start that one. I think you could finish from there. And if you need help, just let me know. All right. This problem, I believe, is part of WebWorks, but also probably should have been before we just did these derivatives, because now we're going back to average velocity. So if you look at the average velocity, we got to have 2 points, right? So that kind of makes this kind of what we did at the very beginning of the section. So this says we have the position of a particle given by the value of tables. So we already have our x and our y values, so we don't have to figure out anything else. We're going to find the average velocity for the time period beginning when t is 2 and lasting for 3 seconds. So this is WebWorks, so please read that question carefully. We're starting when t is 2, so that would be the ordered pair 247. That's where we start. And then we're going to go for 3 seconds. So that doesn't mean we're using this ordered pair. We're going to go 3 seconds from here, so that puts us at 5. That's why it says the interval is from 2 to 5. So that means the other ordered pair we're using is 5103. Okay, that's probably the biggest thing. And again, this is WebWorks, so it's just to help you out with that. All right, so then to find the average velocity, remember that's just the slope. So you would do 103 minus 47 over 5 minus 2. So that gives you 56 over 3. And that comes out to be 18 2/3, 18.666, okay, feet per second. All right, for number 2, we're going to do always starting at 2, and this time we're going to last for 2 seconds. So that means the interval we're going to use is x goes to 2 to 4, right? So that would be still starting with 247, but this time we're going to use the point 486. That's 2 seconds later. All right, so same thing, find the slope, 86 minus 47, 4 minus 2. So this would be 39 over 2, 19.5 feet per second. So this is the average velocity within that 3 second span. This is the average velocity within 2. So what does that tell you is that between the 4th and 5th second, this thing slowed down a bit, right? So it's going faster here. All right, and lastly, we're going to do just for 1 second. So we're going to start at 2 seconds. We're going to end at 3 seconds. Right? So this would be the interval from 2 to 3. Remember, your intervals are just x's, right? So this is the x time. All right, so 51 minus 47, 3 minus 2. That gives you 4 over 1. So this is not a very exciting problem, but that's, again, average velocity. And I believe this whole page is WebWorks. That's why it's kind of here at the end. So make a note, this whole page is WebWorks, so that when you do your WebWorks, you can look at this for some guidance, okay? All right, so that's it for that one. Now let's look at number 9. This is all about, do you understand notation? So there's really no work to do in this problem. We're just looking at it. Well, I guess there's a little bit of work. We got to find the equation of the line, but everything is given to you. So this is, do you understand function notation, derivative notation, and so forth. All right, so what this is, and this is a weird way, it's WebWorks. So it's saying the equation of the tangent line to the graph of all of this is what? So they're asking you for the equation of the tangent line. So you're trying to write, you know, this. That's what they want to know. So when you see your WebWork problem, you'll understand that. So what do we need to find the equation of a tangent line? We need the point and we need the slope, right? Always. So look at what's given to you, okay? They're giving you g of 3 is -3. This is your point right here. That's an ordered pair. So my point is 3, -3. And then what does this mean? What is the derivative of g at 3 being 7 mean? Derivative is the slope. So 7 is the slope of this function at 3. Okay. So again, just notation. Ordered pairs and derivative is slope. So slope is 7. So now that you have that, you can do your equation of the line. Okay. So we got y plus 3, right? Y minus a -3 is y plus 3. Slope is 7, and then x minus 3. So you should end up with y plus 3 equals 7x minus 21. So y equals 7x minus 24. So that's what they want. Okay. So notation. Do you understand the notation? All right, and then in part B, if the tangent line to y equals f of x at 210 passes through the point 0,4, then what is f of 2? Again, that is notation. F of 2 means what is the y value when x is 2? So they gave you that, 10. What is the derivative at 2? Okay, how do you find the derivative? That means you need to find the slope, right? And they gave you 2 points. So if they give you 2 points, and we can find the slope. y2 minus y1, so 4 minus 10 over x2 minus x1, 0 minus 2. So we got negative 6 over negative 2, which is 3. So that would be the derivative. Okay. So just again, knowing what derivative is, knowing what function notation is. So these are web work problems, just testing your knowledge on the notation. All right, now 10 and 11, I'm going to get this so it fits on the page, so give me a minute. I'm not real sure why they gave you so much space on that one. Okay. I'll be able to see both of them. All right, so last two problems again, this is WebWorks. So they're giving you a limit problem and then they want you to express what the function is and what A is, what the value is that you are finding the limit at. Okay, so let's, up here, I'm just going to remind you of our two functions. All right, so there's the one definition, and then we also had this definition. So these are the limits at a point. The more you write these down, hopefully the more you'll remember them. Be good to know those. Okay, so there's our two options for a derivative at a point. Right? We need to know what A is, so these are asking us that. So it's real easy to tell which problem, which function they're using. So for number 10, they're using this function. And for number 11, they're using this. How do I know that? Because this has h going to 0, and this has x going to 6, right? All right, so I know what I'm using. So now I kind of need to figure out which one is which. All right, so let's talk about this one. This is using this, right? So they're telling me that f of a plus h is the square root of 81 plus h, right? That's f of a plus h. So that must mean that a plus h equals the 81 plus h. And the function has to be the square root, right? So if I'm substituting in a plus h, which has to be, so now I'm pretty sure what a is, right? So if I'm plugging that into this function, then the function had to start out to be the square root of x because I'm putting in a plus h in place of x, and I put it right there. So what did I change out of that? I changed that x. So that's where that came from. Okay? And I know that a has to be that number, so it's 81. And let's think about it. This would be f of a. So what is the square root of 81? If I put 81 in there, the square root of 81 is 9, and that's the y value. So that all makes sense. So f of x is the square root of x, and a in this problem would be 81. Okay, so that's based on just looking at the numbers in that formula. Now let's look at 11. Number 11 does this one. So even nicer, f of x is the function. When we do this, we just put the function in there. So there's f of x, 2 to the x. Now, gotta be careful here. You're doing a. So remember, f of a is the y value, a is the x value, and they want a, which is here, so that would be 6. So these problems don't take the work, it's just do you understand the notation, okay? All right, so that should give you plenty to work with on section 2.1. Can't stress enough, again, when you turn in your work for this test and for the quizzes, when you're asked to find the derivative, I gotta see you doing it the long way, no shortcuts. Okay, those of you that know them, pretend you don't know them for now, okay? All right, so work on your homework. Let me know if you need any help and have any questions ready for me. If you have any, have those ready for class, okay? All right, y'all work hard.